Okay, so today we're going to be looking at powers of monomials. Now if you remember, we've used this vocabulary word before. Monomial just means it's a polynomial that only has one term. Okay, so in other words, there's no plus sign, no minus sign, no addition or subtraction. Okay, because addition and subtraction separate two terms. So it's all multiplication or division. Okay, so doing powers of monomials with one term. And of course, powers just means exponent. Okay, so basically what this means is that we're going to be doing one term with an exponent on it. Okay, now these are all examples of a monomial. You have y is a monomial, one term. Okay, 3x is a monomial because it's 3 times x. Okay, so there may be more than one thing in the base now. Okay, over here we have 2ab, 2 times a times b. That's 3 things, but it's all multiplied, so it's one term. It's a monomial. 4c squared. Everything's multiplied. It's still a monomial, so it's okay to have an exponent. And fractions are okay too because they're division. So x divided by 5 is a monomial. So today we're going to be taking these monomials and putting exponents to them. Okay, so we're going to be learning how to do things like this. We're going to be taking the y and raising it to the 4th power. Or taking 2ab and raising it to the 3rd power. 4c squared and raising it to the 4th power. Okay, we're going to learn all of these rules today. Now, the first rule we're going to learn is the power of a product. Product means multiply. Okay, so we're looking at when we multiply two or more things and then we raise that to a power. So here we have 3x to the 4th power, and this is 3 times x raised to the 4th power. So the 3 and the x are inside the base, inside the parentheses. Okay, so let's look at what that really means. 3x to the 4th power really means 3x times 3x times 3x times 3x. Okay, because this means we have 3x multiplied times itself 4 times. So that's 3x times 3x times 3x times 3x. Okay? Alright, now, since 3x really just means 3 times x, then really I just have this. 3 times x times 3 times x times 3 times x times 3 times x. Okay? Now I didn't do anything there. I just rewrote it using a different symbol for multiplication. Now, we know that multiplication is commutative, again, so I can rearrange all these any way I want. So I'm going to take the 3's and put them all next to each other, and take the x's and put them all next to each other. So now I've got 3 times 3 times 3 times 3 times x times x times x times x. Now, we know a shorter way to write this now because this looks like something with exponents. Okay, so here I have 3 times 3 times 3 times 3, so that gives me 3 to the 4th power, times x times x times x times x, that's x to the 4th power. So 3x raised to the 4th power is equal to 3 to the 4th power times x to the 4th power. So, our rule for power of a product, as you can probably see, is just that everything in the parentheses gets the exponent. Every piece of the product gets raised to the power. Okay, so up here we had a 3 and an x, both raised to the 4th power. So when I simplify, I get 3 to the 4th times x to the 4th. Okay, you can kind of think of it like distribution. Okay, because we have the 4 getting distributed to the 3 and the x. Okay, and that's step 1. Everything gets the exponent. Okay, then step 2 is just to simplify what you can. Okay, now there's nothing you can do to simplify x to the 4th. That's simplified. Okay, but when you have a number like this, 3 to the 4th, we can simplify that. So we need to simplify that to 81 x to the 4th. Okay, and that's how I do a power of a product. Okay, I do everything in the parentheses gets the exponent, and then if I have anything that I can simplify, I simplify it. So my answer is 81 x to the 4th. Okay, now here's some for you to try. We're going to simplify these power of a products. Okay, we have 2x to the 3rd, 4abc to the 2nd, and rpt to the 38th. So see if you can use the rule we just talked about to simplify these. Okay, so looking at the first one, again, the rule is everything in the exponent, everything in the parentheses gets the exponent. So I have 2 to the 3rd times x to the 3rd, and then simplify. Well, 2 to the 3rd power is 8, so I get 8 x to the 3rd. And that's my answer for the first one. Okay, same thing for the second one. I have everything in here is squared, so every piece in here is raised to the 2nd power. Okay, so I have the 4 to the 2nd power times a to the 2nd power times b to the 2nd power times c to the 2nd power. Now the only thing here I can simplify is 4 squared, because a squared, b squared, and c squared, that's as simple as it gets. Okay, so I have 16 a squared, b squared, c squared. Okay, and remember, I don't have to put these multiplication symbols, because when I put the variables next to each other, that already means multiply. So that's my answer for number 2. Now, number 3 is even easier. It may look complicated because it has a very large exponent, but these are all variables. So when I give everything the exponent, I get r to the 38th power times p to the 38th power times t to the 38th power. And in this case, since there's no numbers, there's nothing to simplify, I'm done. That's my answer. Okay, so that's the power of a product rule. Alright, next rule. We have power of a quotient, okay, which means division. Okay, like we said, a monomial can have multiplication and it can have division, but that's it. So we've learned our power of a product rule to work with multiplication. Now this is our power of a quotient rule to work with division. Okay, so we have x over 2 raised to the 3rd power. Now let's look at what this means. Okay, this means x over 2 times x over 2 times x over 2. We've got x over 2 multiplied by itself 3 times. Okay, now I'm going to write this with multiplication symbols instead of parentheses. So I get x over 2 times x over 2 times x over 2. Now I can go ahead and multiply. I multiply fractions by multiplying the numerators together and then multiply denominators together. So that gives me x times x times x on top and 2 times 2 times 2 on bottom. Now I can simplify that because I know x times x times x is x to the third power. And I know that 2 times 2 times 2 is 2 to the third power. Okay, so I can see that x over 2 to the third power is just x to the third power over 2 to the third power. So this rule should seem pretty familiar. Everything in the parentheses gets the exponent. Okay? So if you've got a fraction, the numerator gets the exponent, the denominator gets the exponent. Everything gets the exponent. Okay, so I had x over 2 to the third, so that just means I have x to the third over 2 to the third. And then I simplified just like I did last time, and 2 to the third is 8. So x to the third over 8 is my answer to that problem. Alright, now let's see if you can do a few. Alright, now you're going to use the same rule we just used, the power of a quotient rule, to work these out. Okay, now looking at the first one, I have m over 3 to the fourth power, so that gives me m to the fourth power over 3 to the fourth power. Then all I have to do is simplify. M to the fourth is simplified already. Okay, but 3 to the fourth is 81. And you can always use your calculator to figure out what 3 to the fourth is. Okay, the calculator won't do the whole problem for you, but it will do that part. Alright, so then number 2, same thing. I have 5 over x raised to the second power. So that gives me 5 to the second power over x to the second power. And then I can simplify the 5 squared, gives me 25 over x squared. Doesn't make a difference if the variable's in the top or the bottom or in both or in neither. It's still the same thing. Everything inside the parentheses gets the exponent. So number 3, done exactly the same way. I have r over t raised to the third, so I have r to the third over t to the third. And there's nothing to simplify there, so that's my answer. Alright, now, those two don't always happen in isolation though. Sometimes you have problems that have multiplication and division in the monomial. So you might have something like this. 2ab over 4c, all raised to the third power. So I've got multiplication, I've got 2 times a times b, I've got more multiplication, 4 times c, and I've got division. I'm dividing that numerator divided by the denominator. And all of it's raised to the third power. Okay? But I'm going to follow the exact same rule. If you notice, they had the same rule anyway, so when I put them together, obviously I followed the same rule. So everything in the parentheses gets the exponent. So I have 2 to the third power times a to the third power times b to the third power divided by 4 to the third power times c to the third power. Notice the 3 just went to everything. It went to the 2, to the A, to the B, to the 4, to the C. Okay? Then all I have to do is simplify. Okay? 2 to the third power is 8. And then A to the third and B to the third are simplified. And then 4 to the third power is 64. And then C to the third power. Now I can look at this just like a fraction, and the 8 and the 64 will simplify. 8 goes into 64 8 times, and 8 goes into 8 once. Okay, so this becomes just A to the third, B to the third, over 8 times C to the third. Okay, so all I did was the exact same rule. First, the exponent goes to everything in the parentheses, and then all I did was simplify the numbers that I could. Notice, I didn't change any variables because I can't simplify those. I can only simplify the numbers. And then I simplified the fraction, only the number part though. Okay? Alright, so the rule is pretty straightforward. It doesn't matter whether you're multiplying, dividing, or both. Everything in the parentheses gets the exponent. Okay? As long as it's a monomial, which means no adding, no subtracting. If everything is multiplied or divided, then everything gets the exponent. And then you just simplify. Okay, so now try these two. Okay, these are going to have a mixture of multiplication and division. Okay, 4xy over m, all squared, and then abc over 5d raised to the third power. Okay, the first one, again, the 2 is going to go to everything in the parentheses. So that gives me 4 to the second, x to the second, y to the second, over m to the second. And then the only thing here to simplify is the 4 squared, so I get 16, x squared, y squared, over m squared. And that's my answer. For number 2, everything gets the exponent. So I get a to the third, b to the third, c to the third, over 5 to the third, d to the third. Then the only thing here I can simplify is 5 to the third power. Okay, so I still have a to the third, b to the third, c to the third in my numerator. And I have 125 times d to the third in the denominator. Same rule. Okay, all of it gets the exponent. Okay, and now our last rule for today. The power of a power. Okay, now that means we have an exponent raised to another exponent. Okay, so I have x to the third raised to the second power. So let's look at what this really means. This means that I have x to the third times x to the third, right? Because squared means you multiply this times itself twice. So x to the third times x to the third. Now I'm going to go ahead and expand this out. And this is x times x times x times x times x times x. Okay, now I don't really need the parentheses since it's all multiplication, so I can just write it out as x times x times x times x times x times x. And we know a shorter way to write that, since there are 1, 2, 3, 4, 5, 6 x's, I can write that as x to the 6th power. So you can see that x to the 3rd power squared is equal to x to the 6th power. So some of you may be able to look at this and notice the rule. Okay, when you have an exponent raised to another exponent, you multiply the powers together. Okay, that's the shortcut to get the 6. You have 3 times 2 is 6. Okay, the base stays the same, just like it always does. And then we have 3 times 2 is 6. Okay, this one is really our third exponent rule. We had when you multiply exponents, you add them. When you divide exponents, you subtract them. And now this one is when you raise exponents to an exponent, you multiply them. So 3 times 2 gives you the 6. Alright, now here's some for you to try. Okay, now, so we have 2 to the 4th raised to the 5th. Alright, and on number 1, I don't want the number answer. I just want you to leave it as an exponent. Write it as an exponent. Then we have 8x to the 8th raised to the 4th. Then we have y to the 2nd raised to the negative 8th. So just follow your power to a power rule and simplify these monomials. Okay, so here I have an exponent raised to an exponent. So my rule says I need to multiply them. So I'm going to have to do 4 times 5, and that gives me 2 to the 20th power, because 4 times 5 is 20. So that's my answer. Like I said, I don't want the actual number here. I just wanted it as an exponent. Okay, the same thing here. I have x to the 8th raised to the 4th. So I need to do 8 times 4 to get my new exponent. So I get x to the 32nd power, because 8 times 4 is 32. Now number 3 looks a little different, but you're not going to do anything different. You have y to the 2nd power raised to the negative 8th power. So I need to do 2 times negative 8th, which gives me y to the negative 16th power, because 2 times negative 8 is negative 16. Pretty simple. When you raise a power to a power, you multiply the powers. Okay, now we're going to go back to the products and quotients as well and put the powers in there. So now we're putting it all together. So you might have something that looks like this. This is a monomial. Now, up until now, we've been nice and not put any exponents in your monomials, but exponents are in monomials. So now we have 2 times x to the 3rd power times y to the 4th power, all raised to the 2nd power. So we're going to have to use a couple of our rules all together this time. Okay, the first thing is the power of a product. Everything gets the exponent. So this is going to equal 2 to the 2nd power times x to the 3rd raised to the 2nd power times y to the 4th raised to the 2nd power. Now I have to use my power to a power and simplify my number. So 2 squared is 4, and x to the 3rd power raised to the 2nd power is x to the 6th power, because 3 times 2 is 6. And then the y becomes y to the 8th power, because 4 times 2 is 8. So that's the simplified monomial for that problem. Okay. On this one I didn't use my quotient rule, okay, but I have the power of a product because we had 3 things being multiplied, and then I also had to use my power to a power rule. Okay, so now let's look at this one. I have 3x squared over y to the 4th, all raised to the 3rd power. Okay, now in this one I actually have all 3, because I have 3 times x squared, and then I have 3x squared divided by y to the 4th, and then I'm going to have these exponents in here, so I have power to a power. Okay, so I start off giving everything the exponent. Okay, so I have 3 to the 3rd power times x squared to the 3rd power divided by y to the 4th power raised to the 3rd power. Okay, so now I can simplify. I know that 3 squared, 3 times 3 times 3 is 27. Now I'm looking at my power to a power rule. 2 times 3 is 6. So x squared to the 3rd is x to the 6th. And then y to the 4th raised to the 3rd is 4 times 3 is 12. So y to the 12th. So that's my answer for that problem. Okay, so looking at our steps. Step 1, just like I did both times, everything gets the exponent. Okay, then step 2, then you do your power to a power rule. Okay, by multiplying the exponents. Okay, so always start out giving the exponent to everything, and then simplify using your power to a power rule, and you're done. Okay, so now let's look at a couple for you to try. Now this starts out with a bracket, but really a bracket is just a parentheses, so you can treat it just like a parentheses. Okay, so the first one is just x squared raised to the 4th power, all raised to the 3rd power. Okay, I'll give you a minute, and then we're going to look at these 3. Okay, so when we have something like this, and this is power to a power to a power, well, we have to start from the inside out. Okay, so we're going to start by doing x to the 2nd power raised to the 4th power. So I need to multiply. 2 times 4 is 8. So that gives me x to the 8th power raised to the 3rd power. Now I have just a regular power to a power, so I have x to the 8th raised to the 3rd. So I have x to the 24th power, because 8 times 3 is 24. So if you notice, all I did was 2 times 4 times 3, and I got 24. Alright, now, number 2. Again, everything gets the exponent. So I have 1 to the 4th power over 2 to the 4th power times t to the 4th to the 4th power times v to the 3rd to the 4th power. Everything gets the exponent. Okay? The 1 and the 2 got the exponent. The t to the 4th got the exponent. The v to the 3rd got the exponent. Now I can simplify. Okay? 1 to the 4th power is just 1. 2 to the 4th power is 16. Now t to the 4th raised to the 4th, 4 times 4 is 16, so that's t to the 16th power. and v to the third raised to the fourth. 3 times 4 is 12, so that's v to the 12th power. So that's my answer for number 2. Notice, these look more complicated, but they're the same exact rules. It's all about the process and following through with it. Okay, now, number 3 actually pulls back in from earlier, actually having to multiply these things together. So we're going to have to go through this one. Alright, the first thing, everything gets the exponent. So everything in this parentheses is going to get this exponent. Everything in this parentheses is going to get this exponent. Okay, so I have negative 2 raised to the negative 4th power times w raised to the negative 4th power. Okay, and that takes care of this parentheses. Now for this one, I have 4 times 4 raised to the 4th power times w squared raised to the 4th power. Okay, now I can simplify each of these. Okay, so I have negative 2 to the negative 4th power means 1 over negative 2 to the 4th power. Okay, and w to the negative 4th means 1 over w to the 4th. And then I still have 4 to the 4th times and w squared to the 4th. 2 times 4 is 8, so w to the 8th. Okay, so now I can simplify some of these. I know that negative 2 to the 4th power is just 16, and I know 4 to the 4th power is just 256. Okay, so now I'm going to rewrite this. So I have 256 over 16, because I have 256 times 256 times 1 over 16. So the 16 is on bottom, the 256 is on top. That's how I get 256 over 16. Okay, then the same thing here. I have a w to the 4th on bottom and a w to the 8th on top. So I have times w to the 8th over w to the 4th. Now I can simplify both of these fractions. Okay, 256 divided by 16 is 16, and then w to the 8th divided by w to the 4th, when I divide like bases, I subtract the exponents. 8 minus 4 is 4, so I get w to the 4th. So all of this just simplifies to 16 w to the 4th power. So that's today's lesson. We did powers of monomials. We learned how to do power of a product and power of a quotient, which were the same thing. Everything gets the exponent. And we learned how to do power to a power, which is done by multiplying the exponents together.